Hello, my form twos. How is everyone doing? Okay, I hope you are doing well. Okay, back after a week of break. Alright, so I hope you rested well for that 1 week. Okay, welcome back to our class for June, week 1. Alright, so today we are going into a very important subchapter which is called electric current. Alright, electric current. Okay, out of all the subchapters and all chapters, I personally think this is the most important and the easiest for you to score. Alright, so let's refresh a little bit. Last 2 weeks we learned about static, okay, which is electric charges in insulator. Alright, so today we are going to learn the proper one, which is conductor, okay, electric charges in conductor. Okay, so first let's look at electric current. What is electric current? Electric current is the flow, okay, not electric currents, okay. What is electricity? This subchapter is actually called electricity. Okay, so what is electricity? It is the flow of electric current, okay, through a conductor. Okay, so last 2 weeks static is about in insulator, only in insulator. Remember, we use balloons, we use a comb, okay, we use acetate, those plastic stuff. This time electric current is only in conductors, okay, in conductors like metals, okay, wires, okay, copper, whatever. All right, so let's look at electric current. Okay, so what is electric current? Basically, electricity is the flow of electron. Electric current is flow of electron. Okay, if you don't remember what is electron, let me refresh a little bit. Okay, an atom has proton and neutron in the middle. Like I said, they don't move because they're so heavy. And then the surrounding spinning one is called electron. So electron, when it flows from one atom to another atom, you get electricity. Okay, you get lights. Okay, you get lights, you get electricity. All right, so that is what we meant by electric current. Okay, so let's look at electric and current flow. Okay, electron and current flow. Okay, this part is not so important because this is more to physics stuff, but it's good to know. Okay, I'm sure you recognize your battery. Okay, and I'm sure you know battery has positive and negative. Okay, and then we have a switch here, we have a light bulb here. Okay, normally we use light bulb lah. Okay, so electron flow. Okay, electron flow will always start from negative because electron itself is negative, remember? Okay, proton is positive, electron is negative. So they will always start at negative. They will flow from negative to positive. Okay, negative to positive. This is not what we usually learn. Normally, we usually learn, okay, the one you learn in primary school or the one you know is always electric current flow. Okay, you start from positive, you flow all the way to negative. I'm sure you know this. Okay, so if they ask for electric current flow, which most probably they will ask, okay, I'll circle here, most probably they will ask is from positive to negative. If they ask for electron flow, it's the other way around. Okay, you might ask why. This is not your concern. This is physics stuff, like I said. Okay, most of the time you know electric current flow will do. Okay, very seldom they will ask electron flow. All right, so let us introduce to something what we call Ohm's law. Okay, what is Ohm's law? Okay, Ohm is the guy who found electricity. He's the first guy who proposed this. So today, electricity, all of us use his law, his formula. Okay, so we have 3 terms to learn. Okay, 3 terms here. Okay, I'm not sure whether you have seen this. Okay, but there we go. Okay, so first term we call it current. Okay, which is the electric current, like I told you just now. Okay, and then second term is voltage. Okay, I'm sure you have seen this on your wall. Okay, the plug says 240 volt. I'm sure you've seen this. Okay, voltage. Third is resistance. Maybe you have not seen this before. Okay, so what is the I, the V, and the R? These are symbols. Okay, these are symbols. Okay, instead of writing the whole name, we write symbols. Okay, you might say, hey sir, what is current I? What is This one you don't ask me. Okay, so let's explain them one by one. Okay, what is current? Okay, current is the rate of flow of negative charge. You might think, what the hell is that? Okay, think of it this way. Just imagine electricity is a river. Okay, can you see electricity is actually a river? Okay, can you see? It's like a river flowing from one end to the other end. Okay, electric current. Okay, I don't like to use this. Okay, you can cancel this. Okay, think of it this way. Electric current is the width of river. Okay, the width of river. Large current means river very wide. Small current means river very narrow. That's all. Okay, all you need to know. Okay, in fact, English lesson, what is current? Current means the flow of something. Wow, the river current is very strong. Okay, means the river is very wide. Okay, very strong current. I'm sure you heard of this. Okay, so this is the meaning of current. Okay, let's look at voltage. Okay, what is voltage? Voltage is the electrical energy needed to move electrical charges from one point to another. What the hell is this? Okay, let us use the river analogy again. Okay, so just now current is the width of river. Think of it this way. Voltage is the speed of the river. Okay, how fast it is moving. High voltage means the river is flowing very fast. Okay, low voltage means the river is very slow. Okay, so if you think of it this way, okay, let me find a space. Okay, if let's say high current, low voltage, what does it mean? Means the river is very wide, okay, and then the river is going very slow. Okay, if it is low current, high voltage, it means the river is very narrow, but it's going very fast. Okay, so think of it this way. Very simple analogy to understand. If you say, how about high current, high voltage, means it's very wide, going very fast. If it's low current, low voltage, it's very narrow, going very slow. Okay, very simple. Okay, so let's look at the last one. Resistance. Okay, what is resistance? Resistance is resistance. Okay, what you are experiencing. Okay, let's say now you are running very fast. Okay, you're running 100 meters. What is resistance? Resistance is the wind coming at your face. Okay, so the wind is slowing you down. Whatever that slows you down is resistance. So same case here. Resistance is the characteristic of an electric conductor that opposes. Okay, can you see? Oppose. I'm fighting it. Okay, oppose the flow of electric current. Okay, like I said, river just now. This is the rod. Okay, this is the rod. Okay, so just now here you can see. Okay, so this is the rod. Okay, the rod is slowing the water down. That's why rod is the resistance. Okay, okay. I want to tell you this. Every conductor has resistance. Okay, normally we use the one with the least resistance. The less the resistance, the better. Because if my wire has a lot of resistance, there's a lot of electricity wasted. You get what I mean? Because all my flow is blocked by the stone. So the river is very wasteful. I don't get water. Okay, which we don't want most of the time. Okay, so I hope you understand this. I, V, and R, 3 terms. Very simple analogy. Okay, you must understand. Okay, so of course they won't ask for this lah. Okay, this one in exam. Okay, what's the meaning of electric current? Okay, what is the meaning of voltage? Normally they won't ask this. Okay, even if they do, it's only 1 mark. I don't recommend you spend so much time memorizing this just for that 1 mark. Okay, so just give it up. Okay, never mind. Let's look at measure. Hey, how do you measure ampere? Okay, sorry, how do you measure current? We use something called ammeter. Okay, okay, let's not talk about the measure first. Let's talk about unit first. Okay, so the unit for current we use ampere. This is SI unit, okay, ampere. That's why, can you see the symbol here is A? Okay, so don't confuse. Just now the I is for the current, okay, for the thing I'm measuring. But for the unit, I'm using A. It's different. It's just like length. Okay, the symbol for length is L. Okay, L. Okay, but for the unit of length is meter. We use M. So same case here. For current, okay, the symbol is I. For the unit is ampere, A. Okay, so and then volt. Okay, voltage we use volt. very simple, and then it's V. So the voltage is the simplest one. Everything is V. Okay, and then for resistance, okay, remember who found electricity? It's our Mr. Ohm. Okay, so now we use Ohm. Okay, we use his name Ohm. Okay, and then we use this funny symbol. Okay, what is this symbol means? This symbol means omega. Okay, it is a Greek alphabet. Okay, Greek alphabet, we use alpha, beta, gamma, lambda. Even the pi, okay, the pi you learn in circle, it's a unit. Okay, it's a Greek alphabet. And then for here, we use omega. Okay, omega. You might see a watch brand called Omega. Okay, they're using this symbol. Okay, so how do we measure this? Okay, because current is ampere, so to measure ampere, we use ammeter. Okay, ammeter, very simple. And then to measure volt, we use voltmeter. Okay, very simple. Okay, and then for ohm, do you use ohm meter? Yes, we use ohm meter, but you don't use ohm meter. We can calculate ohm by using ammeter and voltmeter. Okay, as long as you have these two, we can calculate the resistance. How? We'll talk about this later. Okay, calculation is the main part of this chapter. Okay, of this part anyway. Okay, so how do you use ammeter? Okay, this part I wouldn't recommend you to focus. Okay, so what is it connected by series, connected in parallel? Okay, you don't need to know. Okay, this one we will learn next week. Okay, so let's look at Ohm's law. Okay, there you go. What is Ohm's law? Okay, Ohm's law says that V equals to IR. Okay, I like to memorize this way. I don't like this. I like this way. Okay, V equals to IR. Ver. Okay, V equals to IR. This is Ohm's law. Okay, so if you move the I here, you get R equals to V equals to over I lah. So the same thing, but I like to keep it simple. I like to remember as V equals to IR. Okay, so like I told you just now, if you have voltmeter, you will know the V. If you know ammeter, you will know the I, the current. By knowing V and I can calculate my R. Okay, that's why we don't use ohm meter. Very simple, because you have V, you have I, you can calculate the R yourself. Okay, very simple. Okay, so what Ohm's law says, this one you need to memorize. Okay, the current that flows through a conductor is directly proportional. What is it directly proportional? Means increase together. Okay, increase together. Okay, which means, okay, I'll draw a graph. This is V and I. If V is 0, I is 0. Okay, if V is 1, I is 1. If V is 2, I is 2. If V is 3, I is 3. Okay, and so on. Okay, this graph looks like this. This is the meaning of directly proportional. Increase like that. Okay, not like this, or like this, or like this, or like whatever. Okay, if it's straight line, we call it directly proportional. Means increase together. Okay, so that's the meaning. Okay, so that's the meaning of Ohm's law lah. You only need to memorize this. Okay, so that's pretty much it of this chapter. All right, let's do some calculation. This is the difficult one. Okay, because this part is 80% calculation if you look at it. Okay, so number one. Okay, for calculation, I like to label my stuff first. I always like to label my stuff. Okay, I don't confuse myself. So where the voltage of 3 volts, so this is the V, is applied across the conductor, the current is 0.5. So this is I. What is the resistance? So R, I don't know. So how do I calculate? Very easy. Okay, if you want to use 3, we use the R equals to 3 over 0.5, can. So you get 6 ohm. Okay, don't forget the unit. A lot of my students, they calculate everything correct, but unit they didn't write. All the marks taken away. So please don't do this. Okay, so next, number 2. The figure shows a simple circuit. Calculate the resistance of the light bulb. Okay, means they want the R. Put a question mark here. If the voltmeter reading is 12, okay, it means this is the V, and the ammeter reading is 3. So this is the I. Okay, so R equals to V over I. You will get 4 ohm. Okay, if you are confused, you are scared, you can always write the formula of as V equals to R equals to V over I, and then you sub it in. Okay, and then you get your answer. Okay, this is simple maths. If you say, sir, I don't know how to move this stuff, don't ask me, go and ask your maths teacher. Okay, why are you not paying attention in maths anyway? Okay, so number 3. The figure shows an electric circuit. Okay, what will be the reading of the ammeter when the switch is closed? Okay, what does it mean by the switch is closed? Means if this is the circuit is complete lah. Okay, so you don't need to care about this. They want the reading of the ammeter, which is asking you what is the I. Okay, they will use a lot of way twist and turn to ask you, but the meaning is the same. Okay, so what is the 2 ohm? This is the R. 10 volt. This is the V. Okay, so how do you calculate I? So V equals to IR. So I want my I, so I equals to V over R. Okay, you move your R down. Okay, this is basic maths lah. Huh? So V is 10, R is 2, my I is 5A. Remember, current is ampere. Okay, don't forget. And then number 4, what is the reading of ammeter shown in the figure? Okay, means what is the I? Again. Okay, so this is my V, this is my R. So use back the same formula. V equals to IR. I equals to V over R. My V is 10, my R is 4. 10 divided by 4, you should get 2.58. Alright, simple. You might say, sir, the exam will ask like this. Yes, exactly. If you can't score for this one, I don't know what to say. Okay, you know your in front part, all the biology part, you need to write long, the nutrition part, you need to write long. This one is so simple. If you can't score, I have nothing to say. Okay, give me the marks. You don't want to give me lah. Okay, so number 5. A light bulb is connected to a series to a 12 volt battery. So this is my V. If the resistance of the light bulb is 6, so this is the R. Calculate the current. So means I don't know my I. Again, V equals to IR. I equals to V over R. So 12 over 6. I should get 2. Okay, so let's continue. Number 6. What is the reading of the ammeter shown? Again, what is my I? This is my V. This is my R. Okay, like you see, I always like to label my stuff, no matter how easy the question is. Okay, so excuse me. So I equals to V over R. Okay, V is 6, R is 12. You should get 1 over 2, which is 0.5. Okay, always give your answer, because electricity, always give it in decimals. Okay, I won't give it in okay, what do you call this form? Okay, always give it in decimals. Okay, so not in fraction forms. Okay, so number 7, what is the reading of the voltmeter? Means what's the V? Okay, I have my I have my R. So V equals to IR. This one don't need to move, you just put it in. Okay, 1.5 times 3, you should get 4.5 V volt. Okay, resistance is 4. Okay, this is R. Okay, ammeter reading if the... Okay, what is potential difference? Okay, when you see this word, potential difference means voltage. Okay, put it here. Okay, put it here. Potential difference. Okay, some question that like to trick you like this. I have a student kernel this before. So what is potential difference? Potential difference is voltage. Okay, this is a way they trick you. Okay, so means this is the V. Okay, so V equals to IR. Now I want my ammeter reading, means I want my I. Okay, so I equals to V over R. So 5 over 4. 5 divided by 4, we should get 5 divided by 4. 1.25. Okay, A. Okay, so simple. That's all. Okay, so let's look at the relationship between current, voltage, and resistance. Okay, this is the graph I drew you just now lah. Okay, so can you see, when the lower the voltage, the smaller the current. The higher the voltage, the greater the current. You increase, I increase. You decrease, I decrease. This is the meaning of directly proportional. Please memorize this word. Directly proportional. Okay, so I don't know whether you have learned straight line in maths. Okay, what is gradient? Gradient is the steepness. This thing is the gradient. Okay, so I'm not sure you have learned y equals to mx plus c. Okay, so m is the gradient. So gradient is the resistance lah. Okay, because the y-axis is voltage, the x-axis is current. Okay, and then the c is 0. Okay, so the m here is resistance. I'm not sure you have learned this before. Okay, so Good to know. Okay, so if okay, this graph looks a bit funny. Why is it resistance and current? This one you don't need to know. Okay, you don't need to know. Okay, so what is inversely proportional means you increase or decrease. Okay, you don't need to know this. Okay, so electrical circuit and components, all these symbol, I'm sure you already learned this, like you already know this. Okay, so a switch looks like this. Okay, this is a symbol. Only draw this, don't draw the whole switch out. Okay, and then dry cell is battery lah. Okay, dry cell looks like this. Voltmeter is a V. Okay, ammeter is a A. Okay, what is galvanometer? Galvanometer is also like ammeter, but galvanometer will show the direction. Okay, if current is flowing that way, galvanometer will show here. If it's flowing that way, it will show here. Okay, but ammeter is only from 0 to maybe 10. Okay, they won't show you the direction. Galvanometer will show direction. Okay, so if you see a G in exam, G is equal to A. It's the same as ammeter, so don't panic. Okay, and then this is your bulb, light bulb. Okay, we draw an X. Okay, or sometimes you draw it like this. Okay, I like to draw it like this. Okay, and then resistor. Okay, what is a resistor? Means it has resistance. Okay, normally it's a fixed resistance. Maybe on the resistor here you can see 5 ohm. Okay, maybe it says 10 ohm. Okay, it will show you. Okay, so what is a fuse? Okay, what is a fuse? Fuse, if it's normally you don't learn this, but okay, fuse is when you have extra current, this thing will break. It's like a safety device. Okay, let's say now this bulb has a fuse of 5 ampere. Okay, imagine lah. So if let's say suddenly got lightning strike, this 10 ampere goes to this lamp. So to prevent this lamp from being damaged, the fuse will patah. Okay, so fuse is a very cheap thing, like a 50-cent one. Okay, instead of one light bulb, which is 10-20 bucks. So it will protect you. Okay, the function of the fuse is to protect you. Okay, so what is a variable resistor? We also call this a rheostat. Okay, variable resistor means you can change. Okay, it's not like just resistor is fixed. If the resistor says 5 ohm, means forever it will be 5 ohm. But variable resistor you can change. Okay, normally there's a knob you can turn. Okay, like your water heater. Okay, your water heater. When you change the temperature, you're actually changing the resistance. The higher the resistance, the hotter the water. Okay, so it's just a simple electrical circuit. Same as a speaker. When you turn on the volume, you are changing the resistance to higher. So more electricity is turned into sound energy. That's why you hear louder sound lah. Okay, very simple concept. Okay, so I hope you understand. Okay, so this series and parallel circuit, we will go into it next week. Okay, also very important part. Okay, after we have done this, I would say this chapter is done. Okay, we have magnet also. Okay, this is magnet is easy. Okay, no calculation there. Okay, so let's look at our exercise. Okay, there you go. The first question is already there. What is electricity? Electricity is the flow of electric current through a conductor. Okay, must be a conductor, cannot be insulator. Insulator is for what do you call it? Electrostatic. Okay, electrostatic. Okay, so next. Okay, diagram 4 shows two instruments used in the measure of current and voltage. So can you see an A here? This is an ammeter. Okay, so can you see a V here? The V is a voltmeter. Okay, name instrument P. This is an ammeter. Okay, so what is the function? To measure current. Okay, oh sorry, electric current. Okay, in a circuit. Okay, please don't say measure ampere. That's wrong. Okay, I don't want the unit. I want what you are measuring. Okay, you don't say I measure the meter. Okay, but I measure the length. Okay, so what is Q? This is voltmeter. Okay, this is to measure voltage in a circuit. Alright, so state the unit. Now they want the unit. So this is the ampere. This is ampere. Okay. Okay, good question. Should you write symbol or should you write the full name? For me, I will write both. Okay, this is volt, V. This is ohm. Okay, omega. Okay, how must instrument P and Q be connected in the circuit? Okay, I know we haven't learned this, we'll learn this next week, okay? But for ammeter, we connect this in series, but for voltmeter, we connect this in parallel. Okay, you don't normally see this question. Okay, if you must know what is meant by series. Okay, series means the bulbs are connected like this. Okay, like one straight line. Parallel means it's connected like this. Okay, which means for series, if you switch it on, all three will switch on. Parallel, you can switch on one by one. Like your house is using parallel. Okay, I don't think your house is using series. If your house is using series, means you switch on this light, everything in your house will turn on. That would be a very stupid design. Okay, so your house is using a parallel circuit. Okay, not a series. Okay, so you might ask, sir, why is the ammeter using series and voltmeter using parallel? This is physics stuff again, like I said, so you don't need to know. Okay, if you must know, welcome to form 4. Okay, we'll see you in form 4. Okay, we will learn this in form 4. Okay, so F, state Ohm's law. Okay, a lot of students will just straight away write V equals to IR. Okay, you'll get a big cross, okay, in your face. So how do you say? Okay, you can say the resistance. Oh, sorry, not resistance. Okay, you remember when I increase, you increase. So voltage in a circuit, okay, you can also say in a circuit lah. Okay, you can just say voltage is directly proportional to electric current flow. Okay, so means V increase, I increase, voltage increase, current increase. That's the meaning of directly proportional. That's why I say memorize this word, proportional. This is the keyword of what you should answer. Okay, directly proportional. Okay, state the direction of flow of current. I want current flow, not electron flow. Okay, from positive, okay, to negative. Okay, so not negative to positive, that is electron flow. Remember, electron itself is negative. It starts at negative. Okay, so H, draw and label a simple circuit which consists of a dry cell, okay, connecting wires, switch and a bulb in the space provided. Okay, show how you connect an ammeter. Okay, so you draw a dry cell, you draw wire, you draw a switch. I will put my switch here. Okay, and then you draw a bulb. Okay, how do you connect ammeter? Like I said, ammeter you connect in series. Okay, means ammeter you put it in the middle. Okay, because you can see everything is connected together. But voltage you connected in parallel, so you put your voltmeter here. Okay, can you see there are two parallel? That's the meaning. Okay, so please don't put your voltmeter here. It won't work. Okay, it won't work. Okay, so don't do it like this. Okay, also don't put your ammeter like this. Okay, no, it won't work. Okay, it has to be this way. Okay, so number one, what would happen to the following when the number of cells are increased? Okay, normally question they will say battery, they will say cells, which is the same meaning. Okay, because there are a lot of dry cells. You have battery, you have so many types of batteries. Okay, that's why they say number of cells. Okay, so number of cells are increased in the circuit you have drawn in H. Means I put more battery here. What happened to the brightness? Okay, of course it increases. Okay, the more battery you put, the brighter the light bulb is going to be. Of course, there are so many you can put lah. If let's say the bulb uses 3 volt, if one battery is 1.5, okay, so if you put 2, it's 3. Of course, it's normal brightness. If you put 3, can you do it? Yes, you can. But the bulb is going to burst soon. Okay, it's going to break. Okay, because it's 4.5 volt, it's more than the voltage. Okay, so number 2, the reading of the ammeter. The reading of the ammeter will increase as well because I'm using more battery. Okay, and then the reading of the voltmeter, of course, it will increase as well. Okay, so there you go. Okay, basically they're asking you V equals to IR lah. Okay, I'm increasing my V because I'm putting more battery into this. Okay, so the R will remain the same. Okay, R doesn't change because the resistance of the bulb doesn't change. You still have one light bulb, so it doesn't change. So when my V increase, of course my I will increase. Okay, which means number 2 and number 3 will increase. Okay, so I hope I'm not confusing you. Okay, this is basic calculation. Okay, so number 9, in an experiment, the current flowing in the nichrome wire, okay, nichrome is a type of metal, okay, it's a type of wire, is measured when different voltage are used. The following shows the installed circuit and tabulated experimental result. So all they give you the V and the A, so they give you the ohm. So what do? You calculate yourself lah. So remember R is equal to V over I, okay, which means this divided by this, okay. So 1 divided by 2, 0.5, you should get 2. 2 divided by 1, you get 2. 3 divided by 1.5, you get 2. 4 divided by 2, you get 2. So can you see? Resistance doesn't change. Okay, a light bulb will always be that resistance. Okay, you don't simply change your resistance. Okay, because resistance is fixed unless you are a variable resistance like a rheostat, the one turning in your water heater, that one. If not, it doesn't change. It will always be that resistance. Okay, so do you need to write a unit here? No, because it's really written for you here. Okay, so B, how to increase the voltage in the circuit. Okay, so how do you increase the voltage? Okay, you increase the number of dry cell. Are they using dry cell? Yes, they are. Okay, so how does increase of voltage affect current flow? When my voltage increase, can you see? When my voltage increase, what happens to the current? Okay, it increases as well. Okay, how about the resistance? It remain unchanged. Okay, or you can say no change lah. Okay, so based on the calculated resistance value, write the relationship between voltage and this. Okay, so basically what's the relationship between R, V and I? So R equals to V over I. We can say V equals to I over IR. Same thing. Okay, so calculate the current using the formula if the voltage is 20. So now I know R is 2. Okay, I give you V. So what is the I? Okay, so I equals to V over R. Okay, because V equals to IR. Okay, you can write this first. Okay, and then V is 20, R is 2. I should get my I equals to 10A. Okay, simple. And then can you use the formula in D to make the same calculation if nichrome wire is replaced by a constantan wire? No. Okay, 2 marks question, normally they will ask a why. Okay, why? Okay, because nichrome wire has different resistance than a constantan wire. Okay, every metal has different resistance. Okay, what is the wire that has the lowest resistance? Normally we use copper. Okay, copper is the best. Why? Because it's cheap and the resistance is very low. Okay, next time if you go to if you see a wire before, wire normally has this thing. This is the insulation. If you use a scissor and cut away the insulation, normally inside you will see a bronze color. That is copper. Okay, if you must compare, silver is actually better. Silver is better in terms of resistance. Silver has even lower resistance. But we don't use silver. Why? Because number one, it is super expensive, okay, compared to copper. Number two, it is super heavy, okay, which is why we use copper. Copper is very light, okay, very easy to, they are very soft, very light, and then the resistance is very low. That's why we use copper. Okay, so let's continue. Sketch the graph using the data. Okay, if you can plot this graph wrong, I have no idea what to say lah. Okay, so when my voltage is 1, current is 0.5. Okay, so here, okay, and then 2 and 1. Okay, 2 and 1, 3 and 1.5, 4 and 2. So you should get a straight line graph. Okay, I use a ruler lah, come on. Okay, so no questions asked, you will always get a straight line. Okay, but if you plot, why is the graph, okay, if your graph looks like this, okay, like this, you're doing something wrong. Okay, impossible, you won't get this. Okay, so number 10, Z conducts an experiment. Okay, let's look at the last question. The video is getting a bit long. Okay, Z conducts an experiment on nichrome wire using the circuit as shown. Okay, so Z moves the clip gradually from Q to R. So it moves from here to here. What does it mean? I'm increasing the length of the wire. Okay, here's the thing. The longer the length, okay, the higher the resistance. Okay, so if you put it this way, the longer the river, the harder it is to travel, because there are more rocks, more resistance. Okay, you get the meaning. Okay, so when I move from Q to R, my R increases. Okay, my R increases. Okay, each time he moves the clip, Z records the reading on the voltmeter and ammeter. What is the hypothesis that Z could be testing the experiment above? Okay, so the hypothesis, okay, the longer the length, okay, of nichrome wire, okay, the higher the resistance. Okay, so based on your answer in A, explain how electric current can be affected by resistance. Okay, they already give you the tip for A, you should write about resistance. Okay, so how about the resistance? So what doesn't change here? V doesn't change here. Can you see? I'm only using one battery. Okay, so if it is 1.5 means it's 1.5. Okay, so use the formula V equals to IR. Okay, so my V doesn't change because V is constant. When my R increase, my I is gonna decrease. Okay, basic calculation. Okay, so imagine if my R, let's say my V is 1. Okay, when my R is 1, my I is 1. If my R is 2, my I is 0.5. So can you see? When my R increase, my I decrease. Okay, I hope you can understand this is basic calculation. So I explain how current can be affected by resistance. Okay, when resistance increase, okay, so electric current decrease. Okay, so besides the factor investigated above, suggest 2 more factors that you can study resistance with the wire. Okay, 2 more factors you can study I'm not too sure what this question wants. Okay, are they asking how do you affect resistance? Okay, let's talk about resistance. Okay, a few things can affect resistance. Okay, number one is the length. Okay, the longer the length, the higher the resistance. One more is area. This is reverse. The smaller the area, the longer the resistance. Okay, which means, okay, what does it mean? If my road is smaller, the harder it is for me to move. Okay, compare small road to highway. Highway is very big, the area is very big, of course the resistance is going to be lower. Okay, so I think that's what they are trying to ask. Okay, so 2 more factors you can study. Okay, I think it's area. That's all. Okay, I'm not too sure what they want. Okay, based on the hypothesis, sketch a line to show the relationship between resistance and current. Okay, so the higher the resistance, the lower the current. So the graph will look like this. Okay, because just now V and I is like this. Okay, because the higher the V, the higher the I. But here is the different case. The higher the R, the lower the I. So the graph will fall down. Okay, so I think I will stop here. Okay, I think I'll stop here. If you attended my live class, of course we will discuss everything, because live class is 1.5 hours, almost double the time, more than double the time we have here. All right, so that's it for this week. Okay, I hope you learned something today. Okay, I wish to stress again that this part is very, very, very important. It is definitely gonna come out in your exam. Okay, but then again, is final exam gonna be there? I don't think so. Okay, so just treat it for your next year's sake. Okay, learn it for your next year, because next year we are going to learn about second part of electricity. Okay, so if you got this part understood, you got this part down, next year is gonna be a breeze. Okay, easy for you. Okay, but if you forgot this totally, next year you have to learn this again, you have to go through this hell again. Okay, I don't know why, for some reason some people, they don't like electricity. They treat this like their bane, their nemesis. Oh no, electricity. It is actually pretty easy to understand, if you ask me. Okay, so that's it for this week. Okay, I will see you again next week. Hopefully the MCU will be soon and we will see each other again. Okay, but that's hoping. All right, okay, so see you again next week. Stay safe and Bye bye.